Dear students, now I will welcome you to solve a new problem, a new practice problem on superposition theorem to find out I naught. Here you can see there are three currents, I1, I2 and I3. This is looking like the circuit that I have previously solved, the circuit of mesh analysis. So in that case, how we could find out uh, this I naught current, or if anyone say that to find out the current that passes through this. Okay, so there are three sources are here, sorry, not two, there are two sources. I'm pretty much sorry, there are two sources, not three sources. So the first of all, I have told you have to make it a frequency domain that has been already in frequency domain, so you need not to convert it. Okay, that's a J are here. J minus J means capacitor, plus J means inductor. That has been already done, so you need not to do anything. That has been pretty much done. There's a phasor form. Okay, you need not to do anything. Okay, so the conversion has already been done. Now while analyze this circuit, you have to choose which source will be active and which will be inactive. If we active this source, so the voltage source will be short circuited, then you can find out the current that passes through in that direction. Okay, after that, in the second portion, when you active this voltage source, this current should be in open circuited position. Okay, that will be in open circuited position, so there will be nothing here. Okay, so that's pretty much important, and after that you can calculate it by just adding these two currents. Okay, just look at it, here. If you just make it a short circuit, so only 5 ampere current passes through here, so there is minus 5. This means that will be the different directions. Okay, it will short circuited. You can easily find out this current will passes through here. Okay, and in another analysis, when you active 20 the voltage 90 degree, so the flow of this current will come it out, and we can find out two currents. Then first of all, that will be I dash and then I double dash. So these two currents has been adding up, and then we can find out it. So that is your homework, that you can find out this. If you find out this, you will understand this analysis very much, it will be very clear to you. Now another theorem, the source transformation, how you can use the source transformation. In source transformation, the source transformation is a tool used to simplify a circuit by replacing a voltage source in series with a resistor by a current source in parallel with a resistor, vice versa. Okay, that means if it is a voltage source, you can also convert it to the current source. How? The impedance which has been in the series section, which is connected in the series section, just make it in the parallel section. Just make the series reactance to parallel reactance, and make the voltage to the current source. Okay, that's very good. You can convert it to the current source. You can easily convert it to the current source. And Vs means V is equal to Iz, IR. Okay, and I is equal to V by Z. So after calculating this, you can convert it. Okay, so source in parallel with resistor or vice versa. That means if V is equal to ZS Is, so you have to first of all find out the Is from here. What will be the current? So there will be Vs divided by Zs. Then draw this and convert this. Suppose here is 10 volt voltages, and Zs is 2 ohms. What will be the current? So current will be 10 divided by 2, that means 5 amperes. Is it right or wrong? It's 5 amperes. So the current source will be 5 ampere, and just connect the 2 ohms in parallel. You have done it. That is the source transformation. Okay, pretty much easy, you know. So let's go to the another section, that the steps to apply. Consider 3 steps to analyze the AC circuit as far as previously concerned, and apply conversion and calculate where appropriate V or I is given. Okay, now let's go. Here is an example practice problem. Calculate Vx. Between this using a source transform. How you can calculate? So here you can see voltage source are given. So we have to use it in a source transform. How we could use in source transform? If we transform the voltage source to the current source, that will be V by Z. Okay, just here V divided by Z. There will be a current source here, and this 5 ohms will be in parallel. Okay, just like this. So now the parallel combination 5 ohm resistance, 3 plus J4 impedance gives this, and if you convert the current source to a voltage source, again you can get this. So just converting the sources around it. After voltage division rule, you can find out Vx, and is a method of source transformation, finding Ix. So there is a math. First of all, you have to convert this voltage source to current source. There is a branch series source that should be in the parallel section, same, and just divide this voltage to this impedance. You will find out the corresponding current source. After getting this current source is the basic current source of that, so you can easily find out the current source from here. And there is another current source. So there are 2 current sources. This source will go through that direction, this source will go through that direction. Then 2 sources will be additive in that branch. This current goes through here, this current goes through here, and you can easily find out Ix from here. Okay, so source transformation is usually helpful while you are converting voltage source to current source. If there are multiple current sources, you can make it to the voltage source as far as it concerned. If it's a multiple current sources, you can easily convert it and using KCL and finding out the current from the circuit. So there is another example of source transformation and finding V output. There is 20 volt. So just again make it to the current source transformation. So there will be a current, then finding out the voltage from here, then just using the voltage division rule, you can easily find out V out from here, V output. So the next lecture I will give you some key points of Thevenin's theorem and what is Thevenin's theorem.